Hello everyone and welcome to a new episode of our Lifehack. My name is Patrick and today we will be covering a feature which has been around for quite a while in our legacy software of AutoGrid, however, which has just been recently implemented into Fidelity. And we are talking about the manual blocking of cavities or in general ZR-Effekts in Fidelity Autogrid. We already did 2 life hacks on how to mesh a ZR-Effekt in Fidelity at the end of last year. So if you haven't seen those, be sure to catch up on those. And today we will do part 3, the manual blocking. As an example, I chose this radial compressor right here, where we have this rather simple cavity up here. I will show you how you can do a manual blocking of this geometry, how you can adjust the clustering, how you can create a matching connection to the main flow path, as well as how to relax the clustering toward the hub. And at the end, we should end up with something similar like this. All right. So let's get started. So as always, we start off in the geometry context where I just imported my geometry. Let's go to the Meridional view. And the first step that I'm going to take here is to add a ZR-Effekt. I can do that by simply clicking on the assembly and say add ZR-Effekt with 2 channel connections. As I already mentioned, we covered that already in a previous life hack. Now I can just select this ZR-Effekt and define my boundaries. Also, I can define my rotor-stator interface, which is necessary as soon as we have a ZR-Effekt with 2 channel connections. That's pretty much all we have to do here. Please be sure that these icons here are highlighted in green. If they are red, means that the boundary is not defined. Then we're done here. I can check if my domain for the ZR-Effekt has been created, which is the case. I can go directly to the mesh context. So we start off with the mesh in the main flow path, and I will just create a very fast grid by applying the wizard to this geometry. I think I will just keep the defaults. Maybe I will decrease the number here a little, but except for that, I will keep the defaults and just run the wizard. This is going to take a second. Right, so now we have our mesh. Next, we will mesh our ZR-Effekt. I will add the Meridional view for that. And as we mentioned in the previous life hack, you could do this by simply apply the automatic blocking to this geometry right here. However, we will not be doing that today. Instead, I will show you how you can block this geometry manually by hand. So essentially, the first step you have to take is you select the ZR-Effekt, and then down here you have the option Edit Mesh, which pops up this property window right here. And on the left-hand side, you have an icon which allows you to create a new face. And that's what I'm going to do right now. All I do is I create a new face and block the left-hand side of this geometry. I'm going to need another block for the interface down here. Oops, I don't know why it is doing that. All right. Let me just finish this up here. Maybe I will speed this up later in the video. So next, I'm going to need some vertices to attach these segments or edges to the geometry. You can do that via the symbol right here where it says Insert Vertex. I'm going to just add 4 vertices at this location. And now you can simply select those vertices and pop them to the geometry. So that's pretty much all there is to do regarding the blocking itself. Now what we want to do is we would like to increase the number of grid points, and we would like to adjust the clustering in the streamwise direction as well as normal to the end wall. So let's do that. Before I start, I press this icon right here, which means connect blocks. Now those blocks right here should be connected. You can check that by simply clicking on this slide right here and increase the number of points, let's say 33. And if those two blocks are connected, the number of points right here will be propagated also to the next block. Next, we will adjust the clustering, and I will be doing that by, let's see, I'm going to keep this edge right here selected and go to distribution. Here I can select an option that is called at both ends, and I'm just going to enter a value of 0.1 millimeter. Right, so now I have adjusted the clustering here. The last step that I want to do is I want to also adjust the clustering in this direction. So I can just select this edge right here. And this time I want to define a wall spacing of a certain value here, but also a number of the cell width here. So I'm going to need both at both ends too. And let me just take a look at my cheat sheet just to make sure that I get the numbers right. Yes, so here I would like a value of 2e minus 5 meters, and here I want 1 millimeter. Let's see if that looks right. That looks fine for me. Here it's going to be the other way around, so I want 2e minus 5 meters right here, where the connection is handled to the main flow path, and 1 millimeter here. That looks good to me. And now the last step, of course, since we adjusted the clustering here, it becomes pretty clear that we are going to need a few more cells in this direction. And I will also use 33 cells for that as we applied normal to the wall. All right, that's pretty much all there is to do. Of course, now we could do some additional optimization here, but I'm going to keep it simple as that. I will exit this tool right here. And now we can continue as we usually do when we do the automatic blocking. I can say add matching set constant lines. Be sure that if you do, or if you add Z constant lines and they are within the bladed segment, you have to reinitialize your topology. All right, otherwise, let's see, let me just do that right here to demonstrate. If I recreate the flow path and the blade-to-blade view, you will get this message saying that you have to reinitialize your topology. And that's precisely what we are going to do. I can just click on the symbol right here where it says initialize blade-to-blade topology and grid points. I'm going to do that. Wait for a couple of seconds. And then when we take a look in our blade-to-blade view, we should see that these Z constant lines are also now visible. Next, what we are going to do is we want to relax the clustering toward the hub. So as you can imagine, let me just enhance the view right here. We have this clustering from the cavity here, and this is necessary to maintain this clustering here at the connection. However, we do not need this at toward the hub. So we want to relax that clustering, and you can do that by simply selecting all Z constant lines, and here you have this option relaxation location. I'm going to choose hub here, and I will just add a relaxation factor of 10 and recreate the blade-to-blade mesh, and then we should be fine. We can verify that by taking a look at the hub at 0%. And as you can see, this clustering right here, this is where the ZR-Effekt or the mesh from the ZR-Effekt is propagated. And as you can see, this clustering matches the remaining flow path pretty well. The last thing we have to check is this is something that you actually do not have to take care of when you do an automatic blocking. But let me just take a look at these Z constant lines right here. Yes, here we have 101, and here I think we have to modify that. Let me take a look. Because essentially you have to make sure that if you want a matching connection right here, that this Z constant line is located at the proper index. And the proper index in this case is 133. Like I said, you do not have to do this if you either are satisfied with a non-matching connection or if you do the manual blocking and then add the ZR-Effekt. All right, so we should be good here. I will just save this project and create a 3D mesh. All right, so let's take a look at the mesh. So we have the matching connection here, which is indicated by the fact that you do not see a patch here. We have our rotostator interface, and we have a matching connection here at the shroud. And as you can see, here the clustering is taken pretty much one-to-one from the cavity, but here as we move toward the hub, you can see that the clustering was, or here that we have the cluster relaxation. We could now also, of course, increase the number of points in the cavity, which would be propagated down to the main flow path. That is all up to you. You can play around and find the solution that is most suitable for you. So I hope this was helpful. Please provide us with feedback, and see you soon. Bye-bye.